Welcome back to the fourth topic in Chapter 12. Yesterday we were looking at arithmetic sequences and series, which we found out were linear. Today we're going to be looking at geometric sequences and series, which we will find out is something that we're very familiar with as well. Before we get there, our learning targets. I can find the terms of the geometric sequence, including the geometric means, which is something we'll talk about. And I can find the sum of geometric series. And so what is a geometric sequence? A geometric sequence, as opposed to an arithmetic sequence, which you're adding the same thing each time to make it linear, a geometric sequence, you're multiplying the same thing each time. So it has the ratio of successive terms is constant instead of the difference. And that would be called the common ratio. What else have we seen that has a common ratio where you're multiplying the same thing each time? That would be an exponential function. So geometric sequences are just exponential. And so an example of a geometric sequence would be 5, 10, 20, 40, 80. What are we multiplying by each time? Times 2. That would be our common ratio. So we have our general rule, our equation, and that will be the first term times the common ratio to the n minus 1. So with an exponential equation where we have a times b to the x, the a is the y-intercept. Well, the n minus 1 is just a horizontal translation. So it moves it over so it can be the first term, just like with the arithmetic sequence. We do that because we have a first term. We don't see the 0th term, which is what the y-intercept would be. So let's take this sequence that we have from up here and find the equation. So we can see that the r we saw was plus or times 2, times 2, times 2. And the a1, the first term, is just 5. So we just need to plug that in. An equals 5 times 2 to the n minus 1. Now, when you do this, it's very important. It's 2 to the power and then times 5. You can't multiply them to get 10 to the n minus 1. That doesn't work. Order of operations. So that's how we can take our sequence and just write it in the general form of the equation. So what else will we be doing? A lot of these problems will actually be very similar to the ones that you were looking at yesterday with arithmetic sequences, except instead of going like plus d, plus d, plus d, it would be times r, times r, times r. But some of the differences is a geometric mean. What is a geometric mean? The mean that we used last chapter, the average, is actually called the arithmetic mean. You add them all up and you divide by the total number. A geometric mean, you multiply them, and then you take the root of that number, that root. Really, we only typically do this between two values. And so if you had a and b, the geometric mean would be a times b, and you take the square root. So if we want to find the geometric mean between 2 and 32, it's going to be the square root of 2 times 32. 2 times 32 is 64. And the square root of 64 is 8. So the geometric mean is 8. Now what is the geometric mean? If we had 2 and then blank and then 32, 2 times 4 equals 8 times 4 equals 32. And so it's the middle point of that geometric series. Or sequence. And into geometric series, adding them together. We need to add all these things. We have an equation, or we're going to find the term of the sum of, find the term of the first n terms, find the sum of the first n terms. This should be sum. In fact, I think pen. Find the sum of the first n terms. And so to do this, we have an equation, just like we had an equation for arithmetic series that yesterday I'm like, hey, use the equation. People are like, wait, there was an equation? Yes, there is an equation. This is the equation. Pay attention to it. It's going to be the first term times 1 minus r to the n divided by 1 minus r. And so we just need two things. We need to know the first term, and we need to know the ratio and the number of terms that we're adding together. That would be an important piece as well. So if we have a sum, k equals 1 to 7, of 8 times 10 to the k minus 1, we need the first term. Well, this is in standard form. The first term is just 8. We need the common ratio. It's 10. Then we just plug it into the equation. S of 7, because we're adding together the first 7 terms, equals 8. It's the first term times 1 minus 10 to the 7th over 1 minus 10. 10 to the 7th is 1 with 7 zeros behind it. 1 minus that is going to be 7 nines divided by negative 9. And then negative divided by negative is positive. 7 nines divided by 9 is going to be 7 ones times 8 is 7 eighths. Which actually makes sense when you look at this. The first term is 8. The second term, multiply by 10, 80, plus 800, plus 8,000, plus it would make sense that we'd have a whole bunch of 8s there. So anyway, we plug it into the equation. It's very possible that the r will be a fraction less than 1. That's okay too. Your number will just be a lot smaller than this. And that's it. That's geometric sequences in series. It's exponential. We're multiplying by the same number to get from point to point. And we'll work on it a bit in class. I will see you then.